Even that utopian kind of view has some questions around it about what will be our purpose as humans if there are these technologies that are solving all these problems.
Yes.
What will be left to solve?
Yes.
You know, I worry about that as a scientist, and the scientific method even. So there's that. But there's also obviously the challenges and risks with AI of, well, twofold. One is bad actors using AI for harmful ends, or the AI itself, as it gets closer to AGI and becomes more agentic, it goes off the rails in some way that harms humanity.
The future of artificial intelligence is moving faster than most people realize. And according to recent insights from Google DeepMind CEO Demis Hassabis, 2026 may be the year everything truly changes. In a recent interview, Demis laid out a vision of AI that goes far beyond chatbots and simple automation. What he described is a future defined by full omnimodels, systems that seamlessly combine text, images, video, audio, robotics, and even simulated worlds into a single intelligent framework. When you take a closer look at what Google is already building today, it becomes clear why so many believe the company is positioned to dominate the AI landscape in 2026. One of the most important ideas Demis emphasized is the convergence of modalities. From the beginning, Google's Gemini models were designed to be multimodal, meaning they could understand and generate text, images, video, and audio within the same system. Instead of treating these formats as separate tools, Gemini blends them together. This convergence allows the model to reason across different types of information at once, leading to much deeper understanding. Over the next year and beyond, this cross-pollination of modalities is expected to accelerate dramatically, unlocking capabilities that simply were not possible with single-mode models. A powerful example of this progress can be seen in Google's latest image model, Nano Banana Pro. What makes this model stand out is not just image quality, but how it reasons visually. Rather than generating an image in a single pass, the model evaluates its own output, makes adjustments, and refines the image step by step. This agent-like behavior is what allows it to produce highly accurate visuals, infographics, and complex compositions. This same reasoning process is expected to extend into video, allowing future models to plan scenes, understand motion, and maintain consistency across time. Video generation is another area where Google already holds a strong lead. The V3 video model has set a new benchmark for image-to-video and text-to-video generation. Many people still underestimate just how advanced this system is, but demonstrations show a level of realism and coherence that few competitors can match. Looking ahead to 2026, it is widely expected that V3 and its successors will improve significantly, with better temporal understanding, higher resolution, and more accurate physics. As video converges with language models, the result will be systems that can not only generate videos but also explain them, modify them, and reason about them in real time. Beyond images and video, audio and live interaction play a critical role in Google's vision. Gemini Live is one of the most underrated AI features currently available. It combines real-time speech, reasoning, and multimodal perception to assist humans in practical tasks. A viral demonstration showed Gemini Live guiding a user step-by-step through an oil change on a car, responding naturally to questions and adjusting instructions based on what it observed. While impressive today, this capability hints at something much bigger. By 2026, improvements in latency, reasoning depth, and knowledge integration could turn systems like Gemini Live into everyday companions for learning, repairs, training, and problem-solving.
What does the next 12 months of progress look like? What do you believe that if we sit here a year from today,
Yes.
and I would love to, what will have changed in the world?
The things that we're pressing hard on are the convergence of modalities. So Gemini, which is our main, has always been multimodal from the beginning. It takes images, video, text, audio, and then can now increasingly produce those outputs as well. And I think we're getting some really interesting cross-pollination by being multimodal. The best example of that is model Nano Banana Pro, which I think shows some astonishing sort of understanding of visuals, and it can kind of create infographics that are really accurate. So I think over the next year you're going to see that progress a lot, and I think, for example, in video, when that converges with the language models, you're going to be seeing combinations of capabilities there. I think the other things we're going to see over the next year, and I'm personally working on, is world models. So we have this called Genie 3, which is like an interactive video model you can think about. So you can sort of generate a video, but then you can start walking around it like you're in a game or simulate. It's coherent for a minute. I think that's very exciting. And then, maybe the other thing is agent-based systems. Bill's been talking a lot about agents, but then they're not reliable yet enough to do full tasks. But I think over the next...
We've heard a lot.
Well, this goes back to the agentic stuff, where I think as that becomes more sophisticated, and it's clear why the industry will build those things, because they'll be more useful. So they're definitely going to happen, but the more agentic and autonomous they are, the more room there is for these things to deviate from what you had intended when you gave the initial instruction or the initial goal. So this is a very active area of research, which is to how to make sure that systems maybe are capable of continual learning or online learning stay within the guardrails that you set. I mean, I think the good news is it's become so big commercially and for enterprises. If you think about renting or selling one of your agents as a model provider to another big business, those businesses will want guarantees around the agent's behavior, what it does with their data, what it does with their customers, and if those things go wrong, they're not going to be existential in any way, but you'll lose the business for sure. So, because why would that business end with that provider? They would choose a different provider that was more responsible and had better guarantees. So I think what's great about that is it will sort of reward, sort of naturally, ideally, more responsible actors.
But it's possible that jump the guardrail.
Potentially, if done wrong. I mean, there was always a possibility where nobody really knows what the big unknowns. I think it's non-zero, that potential. So it's worth very seriously considering and mitigating against. But people give very precise percentages about what the chances of these things go wrong. A P-doom, which I think is kind of nonsense, because no one knows what it is.
So you don't quantify it, but you say it's
non-zero. So clearly, if your P-doom is non-zero, then you use and attention on that. The best case scenario that I've always dreamed about, and why I've worked my whole life on AI, and getting closer to this moment we've been working towards for decades, many of us, is a kind of, I've sometimes called it radical abundance. So this idea we solved a lot of the biggest issues confronting IT and humanity today. So whether that's free, renewable, clean energy, maybe we solve fusion, or better optimal batteries, solar materials, semiconductors, material science. We've solved a lot of diseases. So then we're in a situation where, we're post-scarcity era, and where potentially, humanity is flourishing and traveling to the stars and spreading consciousness to the...
General intelligence, human-capable AI, you don't shy away from it. Some other people say, well, we won't know, or we're already there, or it doesn't. Say that it does matter, and we will know, and you say it's not far off.
Yeah, we're definitely not there now. So,
actually quite close.
Yes, I think we're like 5 to 10 years away, if you were to ask me.
I'm sorry,
I think
say that again.
5 to 10 years away.
Yep.
I think my bar, though, is quite high. So that we define AGI as, a system that exhibits all the cognitive capabilities we have. And that includes inventive and creative capability. There are missing, as all of you have used the current LLMs, they're amazing in some ways, they're really impressive in some senses, they've got incredible, almost PhD level skills in some areas, IMO gold medals and so on, but in other areas they're very flawed still. And so they're these sort of jagged intelligences. So you would expect more consistency from a true AGI, and they're missing other capabilities like continual learning, online learning, long-term planning and reasoning. They can't do any of these things. I think they will be able to, but maybe 1 or 2 more breakthroughs are going to be required.
Robotics is another pillar of the full omnimodal stack. While Google may appear slightly behind in consumer robotics, its progress in foundational robotic intelligence is significant. Gemini Robotics 1.5 represents a major step forward in creating general-purpose physical agents. These robots can perceive their environment, break down complex tasks into smaller steps, and adapt dynamically when conditions change. Unlike older systems that required heavy fine-tuning for each new robot form, Gemini Robotics uses a shared model across different platforms. This flexibility is crucial for scaling robotics in real-world environments. What makes Gemini Robotics especially powerful is its agentic behavior. The model does not simply execute instructions blindly. It thinks, plans, evaluates outcomes, and adjusts actions accordingly. Whether sorting objects, handling household chores, or navigating complex environments, the robot maintains an internal chain of reasoning that allows it to complete multi-step tasks reliably. In the long term, this same intelligence could power humanoid robots capable of assisting with daily life, industrial work, healthcare, and logistics. Perhaps one of the most exciting and less discussed areas of Google's roadmap is world models. These systems represent a fundamental shift in how AI understands reality. Instead of generating static outputs, world models create interactive environments that respond dynamically to user actions. Google's Genie 3 is a prime example. It allows users to generate entire virtual worlds using natural language and then explore them interactively, much like a video game or simulation. What sets Genie 3 apart is its world memory. Actions taken within the environment persist over time, maintaining consistency and coherence. If a user paints a wall, moves an object, or triggers an event, those changes remain when they return. This ability to remember and simulate cause and effect brings AI closer to understanding how the real world works. In 2026, world models could play a major role in training robots, simulating dangerous scenarios, advancing scientific research, and revolutionizing gaming and entertainment. World models are also deeply connected to embodiment. By training AI systems in simulated environments, researchers can test behaviors, strategies, and learning methods before deploying them in the physical world. This reduces risk, cost, and development time. As computing power increases and models become more efficient, these simulated worlds will grow richer, more realistic, and more useful across industries like agriculture, manufacturing, disaster response, and urban planning. Another major reason Google stands out heading into 2026 is its dominance in agent-based systems. While many companies talk about AI agents, reliability has remained a challenge. Google, however, has quietly built some of the most advanced agent systems in existence. One notable example is the AI Co-Scientist, a multi-agent system designed to assist researchers in generating and refining scientific hypotheses. Rather than simply summarizing existing literature, this system proposes novel ideas and experimental strategies tailored to specific research goals. The implications of this are enormous. As these agents improve, they could accelerate scientific discovery by identifying patterns, testing hypotheses, and validating results faster than any human team could manage alone. While these tools may not be directly used by everyday consumers, their impact on medicine, physics, biology, and materials science could reshape entire fields. Google has also developed highly specialized agents for software and security. Its code-focused agents are capable of detecting, debugging, and fixing vulnerabilities in large codebases, particularly in open-source projects. By combining advanced reasoning models with tools like dynamic analysis, these agents can identify subtle issues that might otherwise go unnoticed. In a world increasingly dependent on software, this capability is invaluable. On top of that, Google's data science agents automate end-to-end workflows within platforms like Google Colab. These agents handle data cleaning, analysis, modeling, and visualization, dramatically reducing the time required to go from raw data to actionable insights. When you step back and look at the sheer number of agent systems Google is developing, it becomes clear that this is not experimentation. It is a coordinated strategy aimed at building a comprehensive AI ecosystem. Another major development is Alpha Evolve, a Gemini-powered coding agent focused on scientific and algorithmic discovery. Often described as an AI scientist, Alpha Evolve explores new algorithms, tests them, and refines solutions in ways that mirror human research processes. Combined with other agent systems, this creates a feedback loop where AI not only assists researchers but actively contributes to innovation. When all of these elements come together, the picture becomes clear. Google is not just building better AI models. It is building an integrated intelligence stack that spans perception, reasoning, action, and simulation. By 2026, this stack could enable AI systems that understand the world more holistically, interact more naturally with humans, and operate more autonomously than ever before. Many people still underestimate Google's position in the AI race because much of its work happens quietly or within research labs. But when you examine the progress across multimodality, robotics, world models, and agent systems, it becomes hard to ignore the scale of what is coming. The convergence Demis Hassabis described is not theoretical. It is already happening. As we approach 2026, the question may no longer be whether AI will transform society, but which organizations are best positioned to lead that transformation. Based on current momentum, deep research capabilities, and an unmatched ecosystem of models and agents, Google appears ready to surprise the world. What we are seeing now may only be the beginning of a much larger shift, one that redefines intelligence itself.
It's a very intense time in the field. We obviously want all of the brilliant things these AI systems can do, come up with new cures for diseases, new energy sources, incredible thing. That's the promise of AI. But also there are worries. If the first AI systems are built with the wrong value systems or they're built unsafely, that could be also very bad.
Thinking about AGI a little here. Now, you founded DeepMind with the idea that you would solve intelligence and then use it to solve everything else. And I think it was like a 20-year mission. We're like 15 years into it, and you're on track?
I feel like, yeah, we're pretty much dead on track, actually.
5 years away from, what I guess people will call AGI.
Yeah, I think in the next 5 to 10 years, that would be my, maybe 50% chance what we're defined as AGI, yes.
Well, some of your peers are saying 2 years, 3 years, others say a little more, but that's really close. How do we know that we're that close?
There's a bit of a debate going on at the moment in the field about definitions of AGI and then, of course, dependent on predictions for when it will happen. We've been pretty consistent from the very beginning, and actually Shane Legg, one of my co-founders and our chief scientist, he helped define the term in, I think, early, 2001 type of time frame. And we've always thought about it as, a system that has the ability to exhibit sort of all the qualities we have as humans. And the reason that's important, the reference to the human mind, is the human mind is the only existence proof we have, maybe in the universe, that intelligence is possible. So if you want to claim sort of general intelligence, AGI, then you need to show that it generalizes to all these domains.
Is when everything's filled, marks are filled in, then when we have it,
yes, so I think there are missing capabilities right now, that all of us who've used the latest chatbots will know very well, like on reasoning, on planning, on memory. I don't think today's systems can invent, do true invention, hypothesize new scientific theories. They're extremely useful, they're impressive, but and actually, one of the main reasons I don't think we're at AGI yet is because of the consistency of responses. In some domains, systems that can do international maths Olympiad maths problems, to gold medal standard with our alpha-proof system. But on the other hand, these systems sometimes still on high school maths or even counting the number of letters in a word. Yeah. So that to me is not what you would expect. That level of sort of difference in performance across the board is not consistent enough, and therefore shows that these systems are not fully generalizing yet.
But when we get it, is it then like a phase shift, and all of a sudden things are different? All the check marks are checked, and we have a thing that can do everything. Are we then in a new world?
Again, that is debated, and it's not clear to me whether it's going to be more of a kind of incremental transition versus a step function. It looks like it's going to be more of an incremental shift. Even if you had a system like that, the physical world still operates with the physical laws. These robots, these other things. So it'll take a while for the effects of that, this sort of digital intelligence, if you like, to really impact a lot of the real world things. Maybe another decade plus. But there's other theories on that too, where it could come faster.
Yeah, Eric Schmidt, who I think used to work at Google, it's almost like a binary thing. He says if China, for instance, gets AGI, then we're cooked. Because if someone gets it like 10 minutes, the next guy, then you can never catch up, because then it'll maintain bigger leads there. You don't buy that, I guess.
I think it's an unknown, many unknowns, which is that, that's sometimes called the hard takeoff scenario, where, the idea there is that these AGI systems, they're able to self-improve as future versions of themselves, that maybe they're extremely fast at doing that. So what would be a slight lead, let's say, a few days, could become a chasm if that was true. But there are many other ways it could go too, where it's more incremental. Some of these self-improvement things are not able to kind of in that way. Then, being around the same time would not make much difference. But